Welcome, everyone. Quick disclaimer before I get started, because I hate when folks do this to me. There will be a section here where I work for Tugboat, and I will actually do like a little Tugboat demo in the middle. So I don't want y'all to be surprised that I'm going to actually be doing a little sales pitch of Tugboat in the middle. But generally, there is going to be tips, whether you're interested in using Tugboat or not, that you're going to get value out of this. And also, no matter where you are on the AI hype spectrum, I think you're going to get value out of this. So if you're an AI optimist or you're an AI pessimist or somewhere in between, whether you're actually already shipping AI code or whether you're going to resist that as long as possible, you can still benefit from this talk. And that's because the traditional software delivery lifecycle is broken. And most of us don't even realize it. So to illustrate this, I'd like to share a story. And rather than talk about software development, let's enter the neighborhood of make-believe. Imagine with me a retail chain with stores all over the world called Bridget's Widgets. And Bridget hired 3 widget designers. They dream up the most amazing, incredible widgets you could ever imagine. And to make their widget dreams come true, Bridget hired a team of tinkerers, engineers, builders. So these tinkerers would get descriptions of these widgets from the designers, and whatever the designer dreams up, the designer would write out, here's what this widget should do. And these tinkerers would then take that description, go to their workshop, and try to make that dream a reality. Once complete, if a tinkerer finished one of their widgets, one of the other tinkerer would come over, inspect it, make sure, read the spec sheet, and say yeah, actually, this does what it's supposed to do, and then box it up. And once those widgets are boxed up, they then go onto container ships, get transported over and loaded onto the ship. After the widgets get loaded onto the ship, you'd think, we're good to go, right? We're ready to ship this out to the actual stores that are all over the world, right? But we've missed a critical step in the process of building a widget. Up to this point, the widget designers have not even seen what's been built. So the tinkerers were just working in their workshop. They each reviewed each other's work. And then they shipped it up. They packed it up, and it's about to be shipped off. So what's Bridget to do? Okay, Bridget hires a bunch of quality-minded folks to ensure that the widgets lived up to the high standards of Bridget's widgets. So then, after all these containers are loaded up, these quality assurance engineers would climb aboard the ship, open each container, and investigate and validate the quality of each widget. Inevitably, they would find something wrong, right? Perhaps one widget didn't work well with another widget, or perhaps the tinkerer misunderstood what the designer's vision was, or misunderstood the spec sheet, right? Or perhaps the designer didn't do a thorough job of describing how their widget, maybe the spec sheet wasn't really like a full description of how that widget was supposed to work. And sometimes, maybe the designer did a great job of describing it, the tinker did a great job of creating that widget, but once the designer saw it, they were like, actually, that's not actually what I was hoping for. And in real life, they realized it wasn't a good design. No matter the reason, we now have a problem. The problem is that the widgets are already packed up and ready to ship out. So what's the team to do? Well, maybe Bridget will ask all the tinkerers to board the ship, work nights and weekends, fix those widgets that didn't pass muster. Or maybe they'll identify which container had the unwanted widgets, and they'll painstakingly and laboriously unload them from the ship, careful not to disturb any of the other containers. Or maybe they'll realize, you know what, it's too tedious to unload that container. We're going to mess up some of the other containers. Let's just ship it as is, and we'll ship new widgets on the next ship that goes out. No matter what they choose, this is kind of a dumpster fire process, right? Like when you think through this way of working, it's like, why would we ever work this way? But never fear. The robots are here. They're going to help us, right? So in their spare time, the tinkerers have created a robot that will help them build their widgets even faster than before. So the robot comes in, and how does it help? Well, it's going to hand them the right tools when they need it. It's going to look at how other widgets have been built in the past, and it's going to actually be able to create prototypes of new widgets based on what it's seen from previous widgets that have been built. And so it's going to dramatically speed up the time that these tinkerers can create new widgets. Most of the time. So, we've got robots now. Did we actually solve our problem? No. In fact, we made the problem even worse if you think about it. Because now, if the widget builders can create even more widgets, there's even more widgets to inspect. And the quality of these widgets is even more questionable. And they all lived happily ever after. So, it's kind of a funny story, but this is really like how a lot of us are working, right? This is how a lot of software development is done. We've got the development process where these designs are thought up or new features are thought up. They're written down in tickets. Developers grab those tickets. They create them on their local environment. They push them up. Maybe if you're lucky, you've got automated tests. Those run. You've got peer review. And then all that code is merged in to your trunk branch, and it's ready to ship out. Up to this point in the process, at the merge, the people that actually care about the work that's being done have not seen it at all. It's been other developers that have read the code. Maybe project managers have seen it. And at the end of the sprint, there's this idea that like, okay, we'll have a demo of everything that we did, and if everything looks good, we're going to ship it, right? That's where quality assurance comes in. That's where user acceptance testing comes in. That's what these QA and UAT stand for. And we're all kind of like, this is fine. Like this is how we work, right? And let's dig into a little bit more granular detail of this. So we've got all of these branches that are kind of all merging into this main trunk branch here. So imagine that each one of these kind of represents a ticket. Different developers are working on these tickets. That code is getting merged in, or it's getting reviewed, and maybe it goes through automated tests, and then it gets merged in, right? And then after that, you've got all this work that's come together, and it goes over to a QA environment. At that point, then the QA person finds an issue, right? And so now we're back to what we described before. We've got a couple different options of how typically this is handled. Well, the first one, like we were talking about with the ship, is like, well, we'll just scrub the release. We're not going to release on Monday. We're going to keep working on this sprint until we get this figured out, and then as soon as it's done, then we're going to release it. So that's kind of one of the anti-patterns here. Another one is we'll go through and we'll find the PRs. Hopefully we can extract the ones that didn't pass muster. We're going to revert those merges, and then we'll release what works, right? So this is another way. And this still might end up in working nights and weekends to try to figure this out. Or there's the other one, which is like, well, let's just ship it, and we'll do a hotfix next week, right? So we're going to ship it with all this code that has bugs in it. And maybe we'll even have someone that works nights and weekends to try to get that hotfix ready as soon as possible, because my boss is not going to be happy when they see this live on production. So yeah, this is this workflow, right? We've got development, automated tests, peer review, all that happens. Then thing gets merged in. And the way to solve this, to fix this problem that we have, this bottleneck in our process, is what's called shifting left. So shifting left means you're going to do all of that QA, and user acceptance testing before code gets merged in. So this is what the process looks like once you do that. So now, when a developer is done with their work, it's passed automated tests and peer review, then QA and user acceptance testing can occur. And only after that has passed will the work get merged in. This means the container ship, if we go back to our imaginary world, is always ready to sail. Whatever's loaded onto the ship has already been tested and reviewed. In other words, your stable branch is always tested and ready to ship. This is called continuous delivery. This approach of ensuring that your stable branch is always tested and ready to ship, continuous delivery. So now we can introduce AI, robots, get in there, they can improve the productivity of your development teams. You're already equipped with a streamlined and scalable software delivery lifecycle. Now I'm going to say something next that hopefully is not controversial at all. Don't merge untested AI code. But if we're all working in that old workflow, it's kind of the way it's going to go probably. You know, like there's going to be code that gets merged into your main trunk and deployed somewhere before it's ever actually been tested. So what's missing in our current tooling, in our current hosting platforms, in our current way of working? What we need is automated staging environments for every pull request. What we need is automated staging environments for every pull request. Okay, let me unpack that. So first, we need a real testing site with real data, you know, as real as you can make it, depending on what your security requirements are. You know, if you've got email addresses in your data, those should get sanitized. Whatever other PII or private information, sanitize that data, but use as real data as possible. You need those environments created automatically. And you need those created on every pull request or merge request. So that's, if you're not on the development side of things, that's the, you know, anytime a developer says, my work is ready to be merged in, they will create what's called a pull request or a merge request. And that's the point at which we should have a fully working testing environment. And because AI is in the mix now too, making these developers even more productive, we need this whole process to be super duper fast. We need these environments to get spun up as soon as the pull request gets open. As quickly as you can have an environment after that, the better. So if you add up all of these 5 ingredients, you get tugboat. Or maybe tubgoat. No. Okay, so now we're going to enter into the portion where I'm actually going to show a demo, and I'm going to switch to mirroring, which may screw something up with the recording, but hopefully we'll see. So yeah, this is where, as I gave you the disclaimer before, I'm going to show you tugboat in action, some of the bells and whistles there, and let's give it a shot. So let me switch over to mirror, and this is going to be a live demo, you know, so say a prayer to the demo gods that the internet works and everything goes well. So, all right, let's see here, and it looks like the recording is still recording, so we're good there. Okay, I've got, can you all see this okay? Okay. I've got a Drupal 10 repository here, hosted on GitHub, so that if you're not a developer, this is where all the code lives, is on GitHub in this particular instance. And I've already got this repository wired up to Tugboat. So let me switch over to another window. Loading up Tugboat. The internet is thinking about this. And so here's this repository over on the Tugboat side of things. And the real power of Tugboat in this case, we mentioned we want these environments to spin up super duper fast. We want them to have real data in them as much as possible. The way we achieve that on the Tugboat side of things is with what we call a base preview. So I'm going to go ahead and click preview here on this. This is just a demo site. I'm using the Umami demo. But this is what our base preview looks like. So, transport yourself to a world where this is looks like what the production site looks like as much as possible. This is a fully functioning website, so I can log in here if I want to. Don't steal my password, it's admin. I know you were thinking you were wanting a new password, and that one's already taken. So yeah, this is a fully functioning website here. I can add content, delete content, all that stuff, right? And it has all of the content as well from the production site. Maybe it's sanitized, like I mentioned before. Hopefully it's sanitized. So what Tugboat is going to do is when that pull request is created, it's going to instantaneously clone this environment with all of the data inside of it. It's going to take that branch from that pull request. It's going to merge it into whatever target branch is, which actually will catch a ton of bugs just right out of the gate that you might not otherwise have caught. And then it's going to run whatever deployment steps are necessary to deploy that code to production right then. Okay, so let's go ahead and tinker with this as an example. So let's say I'm over here, I'm a developer, I'm on GitHub, and I check out, there's an issue in there, and it's an issue from the designer. The designer's saying, you know what, I don't like this default logo here. I think we should just get rid of the logo. I would like you to remove the logo from the site. Okay? So I'm the developer. I'm like, okay, I will do that. And actually, I'm going to use AI to help me. So I've got Claude Code, and we're going to go ahead and use that. Let me make sure I'm in the right directory. I've already got a branch checked out. So if you're not familiar, Claude Code is using Claude, which is built by Anthropic. And it's a way to work with a particular project on the command line here. And so I can basically communicate with my code here, and Claude will make changes and stuff like that. So in this case, I want, we're using the Umami theme. I already know some things about Drupal and how this should work. So I'm going to phrase this, remove, or let's call it disable, the default logo in the Umami settings file. And so now Claude's looking through. It's going to try to find the Umami configuration file in my repository. Okay, it found umami.settings.yaml. And it's making a configuration change, which looks good to me. So right now it says use default is set to 1, and it's going to change that to default is 0. So yeah, let's go ahead and make that change. All right, and so now let's just, I'm on a different terminal window here. Look, I'm just going to look at the actual changes. This looks good. So we'll go ahead and stage that and commit it. Whoops. Okay. And now let's push that up to GitHub. And, whoops. Copy this. And now I'm going to create a pull request, okay? So we've got, this is our change. And as I mentioned before, what's going to happen on the Tugboat side of things, as soon as this pull request gets created, it's going to automatically clone that base preview. It's going to check out this branch that I created, this 1, 2, 3, 4 turn off logo. It's going to merge that into our target branch, which in this case is main. And then it's going to run whatever deployment steps are necessary for this site. Deployment steps might be running drush updb, which is like updates the database. Or if you're using SAS, it might be compiling SAS or minimizing JavaScript, all the steps that would be necessary to deploy this code to production right now. So let me make sure I've got this up. So I'm going to hit create pull request, and then I'm going to switch over here so we can see what happens on the tugboat side of things. So I'll go ahead and click create, and then we'll switch over here. So you can see Tugboat's already creating a new preview for this pull request, and we see from main here. So that is the, it's cloned the main base preview here. And if we click in here, we can see some of the things that are happening. Okay, it's already done. Here's the different drush commands that ran. And so if we switch back over to the GitHub side of things, we'll see a few things over here. So this is the GitHub issue. We've got a link to the actual testing environment. We've got a couple other links here in a comment. And then we've got some other things happening down here, some status checks that are happening. So now we've got this workflow, right, where a pull request gets opened, and immediately we have an environment with just this one change applied to it with all of that data. So I'm going to go ahead and click. So now I'm changing hats. Let's imagine now I'm the quality assurance engineer. I've come over here, and I want to check out this site and make sure that this did what we expected it to do. And as you can see, we no longer have that logo showing up, so that's awesome. That's what we wanted it to do. And I'll compare that with the base preview here. So here's that base preview. We still see the logo here. I'm going to switch windows. So here's our new preview. Each of these gets a unique URL. And this is a completely, I can log into this site just like I would in the other one, edit content, check things out. If you've got a complicated ticket that you're working on, and it might need someone to log in and make sure it works as expected. So back on the tugboat side, we've got some other things going on here that I want to show you. Tugboat also has automated Google Lighthouse reports that run, so you can get performance, accessibility, SEO scores on each of these pull requests for different URLs that you want to test. That way you can see not only does the pull request do what it's supposed to do, but did our accessibility score go down or something? Or did our SEO score go down on this pull request? Let's check that out. The other thing that we have built in is visual regression testing. So what visual regression testing is, since we have that base preview, we can take a screenshot of various URLs and then take screenshots of the new preview and compare those. So let's take a look here, for example. Slow internet. So here we've got a screenshot that's still loading of the before, and here we have a screenshot of after, and then in the middle is a pixel by pixel comparison of the two. So you can see what actually changed. And so what the workflow might be here, if we go back to GitHub, let's say I'm that, I need to refresh because, there we go. Let's say I'm that QA person or a project manager or something. I come in here and I see, visual regression testing failed. Let me go check that out. So I'm going to click on the visual diffs. And I can click through each one of these and say, oh no, actually this was an intended change. We wanted that logo to get removed, right? So I can go in and approve those. And then when I go back over here to the GitHub side, we've got all happy green check marks, which we love green check marks, right? They just make us feel good in our soul. So yeah, let me show you a few other things going on the tugboat side of things. So some other fun things. We've got, for developers, if you have created this environment, you can also drop into a terminal in here if you need to debug, like, why? This worked on my local. As soon as I got it pushed up as a pull request and tested on this environment, it's not working. Let me check that out. So maybe I need to run some database queries or something here. So is this big enough? Can you all see this? So in this case, the database is Tugboat and whoops. I've got access to the data here. I can do destructive things too, though. So In this case, I completely wiped out this site by dropping the database. And so now we're going to get once the internet cooperates, we're going to get the Drupal installer here. But again, these are isolated environments. So here's my base preview. It's still working just fine. Completely separate database. And if I do make like let's say that was an accident, we take a snapshot of the preview when it's done building, so I can very quickly reset back to the state it was when the build had completed on this one. So even though I just wiped out the database, we're going to reset here, and then we get everything back. So now I've got my site back, all the data is completely back where it was before. We also do outbound email capturing. So if you're doing anything with email and the preview is sending out email, you can read that email in here inside of Tugboat, and you also don't accidentally spam. Not that I've ever done that. Yeah, so capture outbound emails. We got all the logs here. And we also have a fully featured API. So if you already have automation and you want to wire up with your own automation and say, okay, after the Tugboat preview is created, then I'm going to run these end-to-end tests on it, or kind of wire it into your own automation as well. So you can see, now hopefully you can see, with having a tool like Tugboat in your workflow, how we're able to resolve that issue with the workflow before, right? Where it was like, we can only test things after they're merged in on our staging server or something like that. With this setup, you get a separate environment for every pull request that gets created. And you get it automatically, and you get it super fast. So that's my little Tugboat spiel. And let me switch back to slides. Stop mirroring. And I've got a few more minutes here, so I want to talk about one particular aspect of this that is outside of Tugboat. So this is more just hopefully broadly applicable, whether you're using Tugboat or not. So we're going to get a little nerdy here. I want to talk specifically about data handling, okay? So we're going to focus on 3 areas as it relates to data handling. So first and foremost, with data handling, making sure it's up, yep. With data handling, we want our data handling process to be secure, okay? We also want an efficient process, meaning that this, whatever sort of data handling we're doing, enables the team to work more efficiently and collaborate better. And then we also want to make sure that across all of these different environments that we are developing in and we're testing on, that we have the same data available to it. So first, let's talk about security. Most teams that we work with, I will say, end up sanitizing their data on their local environments. So a developer will pull down a database dump that has unsanitized data in it. And then if they're following good practices, they're then sanitizing things. But there's an issue here, because if the point of sanitization is to protect sensitive data from ever leaving your secure boundary, is it really sanitary if a developer is downloading that to their local environment? So what we recommend is you create sanitized database dumps in a secure environment. Create it within that secure boundary, and then provide that to your developers and your engineers, and provide that to all the environments that are going to need that sanitized data. The other thing that we often see is that all these different environments have different data on them. So you've got your production site, it's got all the content that your, whatever teams that are actually building out the content for these websites, and then maybe that database dump is really big, and so, well, we don't want to import that onto the staging site. Or maybe this staging environment has like test data in it that it's like, oh, we want to test out this feature, we want to test it. But the thing about real data is that it's messy. And when you test with messy data, you find things that you otherwise wouldn't. So I've done a lot of migration work in the past. And for example, if I'm writing a migration on my local environment, and let's say I've got to write a PDF migration, everything might look fine on my local because I've tested a few PDFs and it's a pretty straightforward migration. We've got the file here, and when we migrate it, maybe we'll want to rename it or transliterate some of the file names or move it into a different directory. Everything looks good. And then you deploy it to production, you run the migration, and you realize it's going to take 3 months to complete because there are over 500,000 PDFs on this site. Not that I speak from experience having done this, but yeah. So the thing about working with real data is you're going to encounter edge cases that you didn't think about as a developer, or just as a team in general. You're going to find these things that didn't quite fit the mold of what you thought, right? And so I encourage you, even if you have hundreds of gigs of data in your database, try to get a workflow, and I can't go into detail on how to do this in this short talk, but get a workflow where that data is available in all these different environments. Okay, that's my little data spiel, and let's just recap everything we've talked about so far. So, as I mentioned to start with, the traditional software delivery lifecycle is broken. And no amount of AI is going to solve this problem. And in fact, as we've shown here, it's actually going to make it worse because we're going to have more stuff that needs to be tested by QA and user acceptance testing, and it's going to even be of a higher questionable quality level. And so the way we need to resolve this is we need to test everything before it gets merged in, right? And as we discussed, this is called shifting left. So you move that QA, the user acceptance testing, move it to before the merge happens. And that continuous delivery, again, that's just making sure that your main trunk branch is always ready to deploy. Whatever's been merged in has already been tested and is ready to go. And, oh yeah, I messed up the slides here, but this slide, number 3, is actually different than the previous one. But I did want to reiterate, don't merge untested machine-generated code. And on the data side of things, use as real data as possible in all those testing environments, and sanitize that data in a safe environment. Make sure you've got your data protected before it ever gets onto these other environments. Once you've got all of these in place, once the AI robots get in there and improve the productivity of your teams, the productivity of your development teams, hopefully, then you're already equipped with a streamlined and scalable software delivery lifecycle. So yeah, any questions on stuff that I covered? I know there was a lot. Yeah, go ahead.
Where's the tugboat creating environments live? Is that like a hosted thing?
Yeah, so the question is, where do the tugboat environments live? And it depends. If you go to dashboard.tugboatqa.com and sign up, then and you're using our cloud SaaS product, then it's hosted on Akamai Cloud, is where we have all of our infrastructure. But we do have folks that are on-premise, like for folks that need like tugboat hosted inside of a FedRAMP boundary, then they can run it on their own infrastructure inside of that boundary as well. So, yeah. Yeah?
Yes, can you talk a little bit about the experience working with the visual regression tool within Tugboat? In particular, okay, just to give you a bit of background, this was reaffirmed for a lot of the stuff we're currently using. We coupled our own thing together, not using Tugboat, but Netlify and a bunch of things. But in particular, so one of the pain spots for us is the visual regression tool when you have date-based information that is essentially dynamic. The screenshots were taken yesterday. The testers are coming in tomorrow. They're looking at a calendar. The data is obviously shifted.
Right.
And so we have to kind of get creative and exclude certain areas so they don't trigger the diff tool to say these things have changed.
Right.
They haven't really, right?
Yeah.
It's still operating on the same baseline. Very specific question. Have you encountered this working with Percy's tool, and how do you, if so, how do you work around it?
Yeah, absolutely. So yeah, just to recap the question, if I'm understanding it, is kind of at a high level, how do you deal with, when you're taking visual regression testing, how do you deal with aspects of the page that are dynamic and might be expected to always be different? You know, maybe it's like mentioned with calendars, or maybe it's like a rotating ad or something like that that's in there. Tugboat itself does not have anything to handle that, aside from you can set a threshold for each page of like what is an acceptable tolerance level. But you should definitely talk with Yuri from Diffie. So at there's the Drupal testing trifecta table in the main front area. Diffie has some tooling in there. So if you need more robust visual regression testing, I would say Tugboat's got like a baseline starter visual regression testing tool, and then if you need more advanced things like I need to log in and do visual regression testing, or I want to click, we've got a drop menu and I want to click the button, get the drop menu, then take a screenshot. Or like you're mentioning, where we've got these areas of the page that are more dynamic, I want to block those out and not do a visual diff on those areas of the page. Then Diffie can do a lot of that stuff. So,
Thank you.
Yeah. Other questions? Awesome. Well, yeah, I'd love to connect. If this sounded interesting to you and you'd like to learn more, let's chat for sure. And yeah, thanks for joining. Hope you enjoyed it.